Well, thank you. It's really an honor to be here today with such an incredible group of speakers. I'm really humbled by the invitation. It's great to be here, and I'm going to be talking about a topic that's very passionate to me, so bear with me if I get excited. Hopefully, Dr. Mace whetted your appetite, literally, for reuse a little bit. We'll be talking about the future of reuse in Texas. To do that, we have to go into the past a little bit, but I'll be reading poems afterwards if anybody's interested. So, just to make sure we're all on the same page, sometimes we think about different things when we're talking about water reuse or recycling. I'm talking about, in particular today, the beneficial use of wastewater. Mostly I'm talking about municipal water reuse. There's other sectors of water reuse, as I'm sure you're aware. But you'll hear it, reuse water, reclaimed water, recycled water. It's all the same thing. I'm not really talking about gray water reuse, although we could have another presentation on that some other time. So going backwards, we've really come a long way from the days when we were just trying to dispose of our wastewater, get rid of it. It was awful. And when we did, even though we were surrounded by it, we didn't want to have anything to do with it. We've gone from that to in Singapore, where they're bottling their reuse water and really seeing wastewater as a beneficial resource that can be used for all sorts of beneficial purposes. And so we've been able to come that far largely because of advancements in technology and treatment that have provided us with some really high quality water that can be used for all sorts of purposes. And that's led to a lot of what we're going to talk about today. So, in terms of water supply planning, what role has reuse had? Well, Robert alluded to the Texas water plans. Even back in 1968, in the Texas water plan, this is a quote from the water plan that really showed some foresight from our water planners that return flows, reuse flows, are an essential and valuable water resource that should be managed and administered conjunctively with other water resources. And so reuse isn't a new thing. In fact, if you look into the history of reuse in the state, it's been going on for a long time in various ways. If we jump ahead to 2012, this line that you see, this is the difference between the two lines that Robert Mace showed at lunchtime on his graphs, the difference between the existing supplies and the projected water needs. And the bars at the bottom show what reuse strategies are currently in the water plan for reuse. And the blue bar are existing strategies, so those are strategies that are in place today that have the infrastructure to deliver that water. And then the lighter colored bar are water management strategies for the future that plan to implement reuse in the future. So you can see where reuse falls into the overall water portfolio. It's not going to be the answer to everything, but it has a significant component. Actually, about 10% of the future water supply is currently projected to come from water reuse. So I took out the back of an envelope and decided to do a few little calculations just to see where those numbers fit into what might actually be available. So if you look at the water plan, the projected 2060 municipal demand is about 8.4 million acre feet per year. And if you just say, well, if you assume 40% of that is returned via the wastewater system, and that percentage is going down incidentally because as we implement water conservation programs, we're actually taking away from our reuse supply, which is not a bad thing, but we just have to be aware that that's happening. So if you assume you get 40% of that back through the wastewater systems, then you get 3.4 million acre feet per year. And I need to keep Cindy and Texas Parks and Wildlife Department happy, so we'll assume that 70% of that might be available for reuse, and you can argue back and forth on what that number might be. So that's 2.3 million acre feet per year. And you compare that to the 1.5 million acre feet per year that was in the 2012 water plan, and you get that maybe really on the back of an envelope, there still might be about 800,000 acre feet per year available potentially, and that's just focusing on starting with the municipal demands, remember. So I think there's some more potential out there. 800,000 acre-feet per year isn't going to solve all our problems, but that's a heck of a lot of water. That's some big lakes that you'd have to build to get 800,000 acre-feet per year. Okay, so back to the evolution of reuse. Started primarily in the agricultural sector, and you could argue too how much of that we would call reuse today and how much the water was actually treated back in the early 1900s, but wastewater was used for agricultural purposes dating back at least that far. Started in the agricultural sector and then moved into the industrial sector with power plants and refineries using the water. And then more recently, the municipalities. We had a great example this morning of SAW, but El Paso has a terrific municipal system that's been in place for a long time, a number of other communities. And then up into and primarily those were all non-potable uses. And then more recently, we've really started looking at potable reuse. And that's where I want to focus the rest of my talk. I think there's a lot of acceptance of non-potable use. There's a lot of applications of it in the state. The public accepts it as a good use of our water. But it has its challenges in terms of economic feasibility and putting the purple pipe systems in. You need to have either a very large user or clusters of users in an area to make it economically feasible to get the water, at least so far, until water prices go up enough. But where we can really begin to focus in on using that 800,000 acre-feet plus the other water that's already been identified in the water plan is looking at potable reuse and how do we get there. So it was alluded to earlier, somebody mentioned that we've been doing this for a long time. Dallas-Fort Worth area has very graciously been providing Houston with water for a long time, indirect potable reuse water. I call that unplanned. The scientific term in the reuse community is now de facto reuse, but whatever you call it, we've had unplanned, indirect potable reuse going on for a long, long time everywhere throughout the country where you have a discharge and somebody downstream then diverts that at some later time. But more recently, we've gone into looking at actual planned reuse projects, planned indirect potable reuse projects in the state, and I'll give you an example of some of those. And then, as Dr. Mace pointed out, we've really jumped into the direct potable reuse arena very quickly, and I have some comments about that as well. So, just to give you an idea of the spread of non-potable reuse systems, there's a caveat here in the fine print down at the bottom with the star says, there are other cities. If you're in one that does this and you're not on the map, I apologize. This information is not all that easy to get, but there's a bunch of places that have reuse systems in place now that use them for irrigation, cooling water, other purposes. But if you switch over to potable reuse and talk about the challenges and the future of potable reuse, we have a number of challenges. First and foremost, we have an obligation to provide water that is safe for the public and safe for the public to use. And so we need to keep that in mind at all times when we're talking about this. We have to balance the needs of human and the aquatic life. So there is going to be an ongoing debate and working between the interests of the human needs and the ecological needs to make sure that we achieve that balance. What should the treatment requirements be for potable reuse? There's a lot of potable reuse that goes on in California, for example, where it's primarily groundwater injection, and California has adopted a certain treatment requirements. Are those appropriate for Texas? Are they not? What are the water quality requirements? How do we justify the treatment for potable reuse? And then last but certainly not least is public acceptance. If we don't educate the public and bring them along, then we set ourselves up for a potential setback. And there's several examples of that happening nationwide, internationally, in terms of setbacks when the public wasn't brought along appropriately, particularly when implementing potable reuse projects. So, in terms of regulatory drivers for indirect, you have to talk fast. In terms of regulations, there really aren't specific regulations for indirect potable reuse. They just come into play through discharge requirements, permitting requirements for discharges to surface waters. So there's the surface water quality standards, water rights permitting that has to take place, but no specific regulations that address indirect potable use other than that. And then for groundwater, any reuse that's injected into a drinking water aquifer, of course, has to meet drinking water standards. So there's nothing actually directly related to reuse in the state regulations with respect to indirect reuse. Direct potable reuse, again, no specific regulations other than the Safe Drinking Water Act. And right now there's nothing else in place, but I think there are discussions about potentially trying to come up with at least some sort of guidelines for implementing direct potable reuse. So I'm going to talk a little bit about a couple of the projects that are in place right now. There's a number of projects in the Trinity River Basin. Some of them are more just paper projects in that a discharger has applied for a water right to some water that was already being discharged into a water body, so they don't have to actually build any new infrastructure. They're just obtaining a water right. And some of them are actually planned projects. And then El Paso has a great example of an aquifer project. And then Dr. Mace referred to the CRMWD project, which we'll talk about too. So I don't want you to read all this, but these are all the reuse water rights that have been secured in the Trinity Basin. And the bottom line is it's almost 1 million acre-feet per year of indirect reuse water rights in the Trinity Basin alone. And there's a couple projects that have been implemented that utilize that water in a somewhat innovative way. And they're both involve the use of constructed wetlands. This one is with Tarrant Regional Water District, and they divert water from the Trinity down near Richland Chambers Reservoir, take that water through a wetland to provide polishing treatment. That water goes back into Richland Chambers Reservoir and then back up to their service area primarily in Tarrant County for the city of Fort Worth and other surrounding cities. They have a sister project for Cedar Creek Reservoir that will also involve a wetland, and together those projects will provide the district with about 100,000 acre-feet of additional supply. North Texas Municipal Water District has a similar project down below Lake Ray Hubbard that takes return flows out of the east fork of the Trinity River, pumps them through a constructed wetland, again for polishing treatment, pipes it all the way back up to the north end of Lake Lavon. And they're utilizing return flows from the wastewater that's discharged from all of those red dots there down below Lake Lavon. And again, that provides them with about 100,000 acre-feet per year of additional yield. And then this is El Paso's project. They treat water to a very high level and actually inject it back into the aquifer and are able to reuse that water. Although El Paso has had a pretty good demand for their reuse water for non-potable uses, so I believe, Ed can correct me, but I believe they haven't used this as much as they originally thought they might. And then Robert referred to the Big Spring project. This is one of the direct potable reuse projects that's under construction right now for Colorado River Municipal Water District. And this project will take water from the Big Spring wastewater plant, provide advanced treatment for that water, and then that water will be pumped directly back into the raw water line that goes up to a little reservoir, a small reservoir, and then is delivered to their customers. And so this is one of really 3 direct potable reuse projects in the world that I'm aware of. There's one in Africa that Robert mentioned. There's a very small one in Cloudcroft, New Mexico, and this is the 3rd one. So Texas is really on the forefront with these projects. So what are we doing here with indirect potable reuse or with potable reuse? We're taking We started out with the wetland projects, or with these projects where we're discharging to a lake some kind of environmental buffer where we're getting some benefits of natural treatment, natural detention time, blending, and environmental buffer. And we're starting to shrink that buffer down. So we're pushing the envelope, shrinking that buffer down. The Big Spring project, shrinking that pretty far, making the treatment better. So we're building up the treatment end of it, shrinking down the environmental buffer. Big Spring's taking their water to the raw water line, and it's getting another barrier treatment at the water treatment plant, and then delivering that to its customers. So what will be next? This. So are we ready for advanced treatment going straight to the distribution system? Well, again, Robert stole a lot of my thunder, but this is exactly what Brownwood is considering. And so we really are, at the forefront as a state, without any really regulatory framework for proceeding with direct potable reuse. And I know that the technology is there. The concern is not so much the treatment technology, but there's humans operating these systems, and we really need to make sure that we have the safeguards in place before we move forward too quickly. I really believe that we need to take small steps in this area, because any setback that we have is going to set back water reuse altogether. So we really need to be careful. So with that, there have been a lot of really prestigious speakers up here. I wanted to show my very highly scientific graphs so that I wouldn't feel left out. And you'll see as we go through this, the vertical axis is going to change. So I've got the increasing yuckiness on the vertical axis. And I'm sure you're wondering what these acronyms are. PMS is a very unfortunate acronym for Pristine Mountain Stream. And it wasn't what you thought it was. IPR is indirect potable reuse, and DPR is direct potable reuse. And really what you see is if you have a pristine mountain stream, then you're going to go to the pristine mountain stream before you go to indirect potable reuse, most likely. If you have the option for indirect potable reuse, you're probably going to implement that before you go to direct potable reuse. It's kind of ingrained in us, even though we know as engineers and scientists that the treatment is good. It's going to be hard to sell to the public anyway if you jump right up to the top of DPR. So the more desperate you get, the more you're going to go down up this arrow. Well, as you move up this arrow too, then there's increasing questions. So we know a lot about what's in the pristine mountain stream. We have a pretty good idea about what goes on with indirect reuse, partly because we've been doing unplanned for a long time, but there's been a lot more experience with that. Direct potable, there's still some questions out there about direct potable. So obviously, the more questions there are, the higher we have to raise that treatment level to make sure that we have enough barriers, that we're covering all the unknowns that are associated with it. So there's increased treatment level. And to the last speaker, that means increasing energy. And of course, that ultimately means increasing cost. So there's a cost to all this, and that's if everything goes well. And that doesn't address the cost if something goes wrong, the cost and the setback. So my advice really is, I think there's a huge potential out there. I think we need to be careful as we move forward. I think the drought has brought up a number of issues. It's brought awareness to reuse. But we need to make sure that we're not taking steps that are too big. First of all, we can have an argument about what is direct potable reuse, because where you really draw that line is not really clearly defined. If you were going to have some kind of guidelines or regulations, you have to figure out what it is in the first place. How many barriers do you need? What are the safeguards? What should the water quality criteria be? What should we monitor and how often should we monitor? What can we monitor? How low the level should we be monitoring? And what are the unique operational issues that we have to deal with direct potable reuse? And then finally, can you sell it to the public? I'm just going to guess, but I'm thinking that it might be a little harder to sell a Brownwood or a Big Spring in Austin than it is in Big Spring. So you need to make sure that your public is on board as you move forward, because even if you don't have a project that's unsuccessful when it's implemented, if you get the public opposed to a project, even if it's not implemented, that can set back reuse for many years. You can talk to people in San Diego about that. It's been a real challenge for San Diego. They had a very bad public experience with reuse. So, just my last slide is the caution slide again. Just make sure we know what we're doing before we move forward. So with that, I'll be happy to answer any questions.
Hi, Alejandro Sabronsky with Clean Water Action. I'm wondering if an increase of the usage of reused water in a community like Dallas, would that mean that there's less water for Houston because they're putting less water into the river that goes to their city? And what's the net benefit of reused water if that's the case?
Well, that's an excellent question, and Houston also wondered that, of course, when. But the water rights, the table of water rights that I put up there for you, to get a water right, Dallas had to apply to the TCQ, and the water right is issued. And the city of Houston had an opportunity to protest, and there was a bunch of negotiations really for all of those all of those water rights for folks in the upper part of the Trinity Basin. And there were some negotiations between the Metroplex water providers and the city of Houston that essentially everybody leaves some amount of water, has committed to leaving a percentage of their reuse water in the Trinity to meet the needs of Houston. So yes, it's water that as these reuse projects are implemented, right now a lot of it still goes down the Trinity, but as these projects are implemented, then less and less of it will go down to Houston.
Thank you for your excellent talk. Mark Earhart from the University of Texas. I didn't hear much discussion about pharmaceuticals in the water, which I think Robert mentioned earlier. I'm curious to get your take on that, doing this direct potable reuse. How big of a concern is that, and do we even have the tools to monitor and know what's in that water and know if it's been treated to a level that we should be concerned about or not? I mean, it makes me a little concerned about reusing that water, not knowing what kinds of chemicals might be in it that we can't even detect. Right.
Well, of course, that's the big question is one of the you can call it a problem, but one of the issues is that technology allows us to measure these things at such low levels. So if you look, you're going to find them, and they're at such small quantities. And the question is, do those quantities present a risk to the public health? And there's been a lot of research done in this area in the last 10 to 15 years. And in general, I'd say overall, most of that has determined that they really aren't a human health risk for most of them. But there's always, there's always the potential of one that could be. So, but that's true with any water supply, whether it's a reuse supply or a raw water supply. If you look for it, you might find it, and there could be a risk. And so that's one of the key questions as we move forward. What does it make sense to monitor? And if we monitor it, what does it mean if we don't know if it has a risk or not? So those are the questions that are still need to be answered. But I will say that any of the potable reuse projects that have been implemented have had no significant health impacts, and so they're all very safe. But it's just a matter we want to keep it that way as we move forward.
Thank you.